Okay, the next one we do ASME section at QB, and what will be the size of nozzle? 2 cell weld for nozzle weld configuration confirming figure J UW16, nominal side thickness 28 mm. So there is already we read T1 T2 is 1.25 114 of the nozzle thickness. There is 20, but T1 is 12, so T2 equal to 8. Size is 8 into 1.414 is 12. A radiograph for long seam in new pressure vessel. UW51 of 25 mm thick plate shows 3 mm crack and 6 mm long isolated slag. Your decision for acceptance. 6 mm isolated slag is just 6 mm acceptable, and crack is not acceptable as per UW51. So that is what repair crack accept slag. If it is more than 6, you have to repair. For vessel 2.5 inch thick MDMT specified is 60 degrees Fahrenheit, and the material construction used 516, maybe grade this 70 60. I don't know. That is some problem in cost. The vessel is failed later due to the brittle failure. Let us see 2.5 and 60 degree Fahrenheit. You can see UCS. $66 and next. So there is 516 grade 60. There is 6570, that is in B. And if you go for next one 5560, that is curve C. Let us see if it is 60 or 70. And you go for this 2.5. So if you go for 2.5, yes. So A, B, C, D. There is 71, another is 34. So either B or C. So B is okay because it is 71. Sorry. This is problem because 71 is the minimum temperature and this is 34. So C is okay. That means they are using 70 and not using 60. So they do it without impact testing. That is the problem. And the vessel failed later due to brittle failure. So it is 60, there is no problem. Because that is the temperature, 60 degrees Fahrenheit, and that is lesser than 70. So it is 60 is in C curve. So C curve has a good 34. This is 71. If you increase the temperature of water to 71, there is no problem. Choose the correct hydrostatic test pressure from given options for a vessel with following data. So design pressure 200, design temperature this, MOC this, 573, allowed stress just 18 by 15 into 200, that is 312 PSIG, that is answer. Ambient divided by 675 is given already, so no problem. In liquid penetrant examination, the maximum permitted rounded indication size of circumferential welds with plate thickness up to 1 inch will be around 5 mm. So it is 3 by 16 inch, 4 point something happening. A pressure vessel constructed according to SME Section 8 Division 1 with cell thickness 7 by 8 inch material, construction P4, group number 1. So there is a table UCS 57. There is 4, group 1, group 2. It should be nominal thickness above which but welded joints shall be fully radiographed. So for group 4 it is written 16, that is 5 by 8. And our question is the table a group 4 1 to 16 or 5 by 8, and we go for again question, that is 7 by 8. So full radiography. An in-service vessel with seamless 2:1 ellipsoidal head, 60-inch ID, 400 psi design pressure, corrosion allowance 0, AC is 20,000 psi inspected. Available thickness is only 5 by 8 was observed on the ground portion. The knuckle radius was found to be adequate. Your assessment is UG32F. And 510 746. So 510. Seven point 4.6. So that is how it is. Let's see. In the local region of the head, use the appropriate head formula in the construction code. The central portion of the head, use the hemispherical head formula. For torus spherical head, the radius, use the hemispherical head formula. For crown radius. For ellipsoidal heads, the radius, use the hemispherical head formula. Shall be equivalent to spherical K1D. D is the cell diameter. K1 is given in table 7.1. Table 7.1H is 1/2 the length of minor axis equal to inside depth of ellipsoidal head measured from the tangent. For many ellipsoidal heads, D by 2H equal to 2. Okay. Head thickness in crown portion is still okay for operation. UG32F. Let us see UG32F. A fiscal conical head. Nothing is there. The ellipsoidal head. Acceptable approximation to one ellipsoidal head is one of a knuckle radius is 0.17 of d and a spherical radius of 0.9 of d. Let us see if it is coming under this. They are giving radius, here the giving something else. You can calculate directly. That's all. Head thickness and crown portion is still okay for operation. For a certain nozzle to cell joint, no corrosion allowance is required. Following data is presented. In this you have to calculate as per hemispherical. That is what here they are telling. Just calculate. For ellipsoidal heads, the radius used the hemispherical head formula shall be equivalent to spherical radius k into d. If there is d by 2h, but there is no d by 2h, but you can directly calculate. For a certain nozzle to cell joint, no corrosion allowance is required, and cell thickness is provided 0.42 inch. Nozzle is 3.2. Pad size is 6.4. Thickness of the pad is 0.4842. Pad OD, second and pad thickness, cell thickness is always okay. So your assessment is pad OD is 2D. Pad thickness. Nozzle ID 3.2 is okay. Thickness of the pad is 0.42. Cell and thickness of pad is same. So nozzle ID is okay. For a vertical process column with ID is 48 inch and the height of 98 foot, the hydrostatic head of the bottom distance 2:1 type will be 98 plus 1 plus 1, 100 foot. Into 0.433, 43.3 psi. The following four new seamless standard or spherical heads are available to use for following design conditions. Choose the correct one. So design thickness, you have to calculate 4 times. That is quite a long process. Provided thickness 0.75 inch. Thickness. And that is around okay. You have to calculate 4 times to find the design thickness. If it is this, okay. Not okay, okay, not okay. The calculation should be 4 times. Following four new seamless 2:1 ellipsoidal heads are available. Same, you have to calculate 4 times. No, one time only. Sorry for that. That is design thickness and provided thickness after forming is okay. One time only. Thickness of the new ellipsoidal head given by okay. So there is 0.5. That is okay. So head in head A is to be analyzed according to API 510 for placing the vessel in service for 10 years. The purpose of API 510 analysis, value of crown whose radius can be taken as Torus spherical 72 inch, API 510 analysis, crown radius equal to diameter. (72 inch), correct. They are mixing everything, that's why it is quite difficult. So 10th is A and 11th they are taking is B. Okay. Then head B. Crown radius for API 510 analysis can be taken as elliptical head for API 510 analysis 0.9 of D, 54 inch. That is the crown portion. And head B, crown portion would lie within similar circle of diameter. Lies in the circle 0.8 equal to 0.8 D. (48). Crown portion of head A may be considered as portion lying entirely within the circle 0.8 D. That is A. Then head B, crown portion would lie within the similar circle of diameter 0.8 D. Require minimum thickness. Crown portion of analysis as per 510 for head A shall be head A is spherical head. The crown portion use hemispherical formula. And for B, use hemispherical both. So hemispherical formula is this one. Use it, you get 0.44235 here 449089. So these are for spherical heads, the radius used in hemispherical head. Ellipsoidal, this radius used in hemispherical head formula shall be equivalent to spherical radius. The minimal thickness of a new cylindrical cell with design pressure 555 psi inside diameter 58, S is 20,000, E is 0.85 with corrosion allowance 1/8. Required thickness PR divided by C minus 0.6. P, that is R is 29.125. So you are getting 0.967 plus 0.125 is 1.09. So the higher than that, you take 1.125. After 10 years of service, extensive corrosion was observed on the cell. Cell nominal thickness as per above. Question above. Patch laying entirely beyond 6 inches from the weld. For the vessel above, thickness measured in this area are only 0.96 inch. While the weld area and the corrosion within expected limits, if corrosion allowance required remaining life of 1/6 inch 0.06, the vessel is to calculate T for this pressure. So T is 0.83, which is great. So 0.96 is greater than 0.83. So it's okay. It is safe design condition. We are planning for a hydro test of a vessel with test pressure of 40 kg per centimeter square gram. The calibrated test gauges available are 050, 000, 0. It is 2 times to 4 times within, and minimum should be 1.5. That's all. So minimum is 1.5. So 60 should be. There is no 60. So just take 0 to 100. And the next one is 4 times 0 to 160. If it is not, there is no there, 0.1. 150 is okay. These are the two. Okay, we'll stop here.